Hello guys, this is the most important topic for BSc and MSc students. So what is the topic? Base catalyzed hydrolysis of ester, that means called as saponification. So this is the most important topic. I already told acid catalyzed hydrolysis of ester. So description lo link undi. So if you have any doubt, then you can check it. So acid catalyzed hydrolysis of ester I already explained, and description lo link undi, and subscribe cheskondi meeku videos anedi kanipistuntayi. So coming to the topic, so base catalyzed hydrolysis of ester, that means saponification. So reaction, what is the reaction? This is the ester or C double bond O R dash. This is the ester formation, and this is the NaOH, that means this is base. So coming to the this is all reactants, and this is the products. So coming the product, sodium salt of acid. What is the sodium salt of acid? Or C double bond O R dash place like Na is substituted. So what form? R dash OH is the byproduct. So this is the reaction. This mechanism is now you want to explain. So what is base catalyzed topic for the deep explanation. So the acid catalyzed hydrolysis of ester is reversible and does not go to the completion. So acid catalyzed reaction already I explained, and notes also there. So description link undi, check cheskondi. So in this acid catalyzed hydrolysis of ester is reversible, so and does not go to the completion. So coming to the base catalyzed hydrolysis of ester is possible, and product of hydrolysis is sodium salt of acid and alcohol. The product is what? Sodium salt of acid and alcohol, the formation. This process is called as saponification. So what is the process is called? Coming to the base catalyzed hydrolysis of ester is possible, and the product of hydrolysis is sodium salt of acid and alcohol. This process is called as saponification. So base catalyzed hydrolysis of ester is not reversible. Coming to the acid catalyzed reversible, acid catalyzed hydrolysis is reversible. So coming to the base, this is not reversible reaction. So that's why this symbol is like this. So this process is very important industrially because it is utilized in the formation of soaps from long chain fatty acids. What is the uses? This is the preparation of formation of soaps. So this is the industrial most important. So say BSE2 mechanism of saponification. So I already told the saponification. What is the BSE2? So BSE2 is base catalyzed hydrolysis of ester. Base catalyzed hydrolysis of ester, and it is bimolecule. So this is known as BaC2. What is BaC2? Base catalyzed hydrolysis of ester, and it is bimolecule. So this is known as BaC2. So BaC2 mechanism of saponification is known as saponification is called BaC2 mechanism. The mechanism of saponification is called as BaC2. So what is BaC2? Base catalyzed hydrolysis of ester, and it is bimolecule. So this is known as BaC2. So in this mechanism is possible in 3 steps. So coming to the first step. So there is a so coming to the first step, you have to take this ester or C double bond O R dash plus you have to take the base. I already is here. So what is the formation? So in this ester, so this is ester and this is base. In this ester, this carbon is electron deficient. So this is more highly electron deficient carbon. So this is the highly electron deficient carbon. So this is the first formation is nucleophilic addition of OH. Nucleophilic. The first formation is nucleophilic addition So in this, what is the nucleophile? OH minus is the nucleophile. So first formation nucleophilic addition. So coming to the OH minus, this is the nucleophile. In this ester, carbon is highly electron deficient carbon. It is attached to the highly negative atom that is oxygen. So what happens here? OH minus is attached to this carbon and this double bond is migrated to like this. So what happens is carbon is highly electron deficient carbon. Coming to the nucleophilic addition OH minus, that means minus charge. When the minus charge is, that is nucleophilic. When the plus charge is electrophile. So when this nucleophile is attached to the highly deficient means plus charge, positive charge. So when the negative charge is reacted with only positive charge, so this OH is reacted with carbon, then you have to write what happens. Carbon is there already, here R is there, you have to write R. That means again OR dash is there, you have to write. So OH is attached, carbon is attached to the OH, then you have to write OH. Again what happen here, O electrophile is attached to this oxygen, because this is the negative charge and this is positive charge, and this is positive charge and this is negative charge. When it comes to oxygen get negative charge. So what happen here, tetrahedral intermediate, tetrahedral intermediate. So what formation is here, tetrahedral intermediate. So coming to step 2, so what happened? So coming to step 2, the intermediate eliminates alkoxide ion. So the intermediate eliminates so alkoxides ion, that means OR, by acyl bond fission. So the intermediate eliminates alkoxide ion. So you have to write the intermediate. So what is the intermediate? Here O minus Na plus and R, again OR dash, here OH. So what happens? The intermediate eliminates alkoxide ion. Here what is the alkoxide form? This is the alkoxide form. Here oxygen is there. When it comes to oxygen negative charge, the bond formation is like this. It is alkoxide ion. So you have to eliminate the intermediate alkoxide ion. What is the alkoxide ion? This ion. You have to remove alkoxide ion. The intermediate eliminates alkoxide, that means OR, by acyl bond formation. What is acyl bond formation? This is carbon oxygen OR, that means carbon and OR bond is the acyl bond formation. So this is the acyl bond fission. You have to eliminate acyl bond fission. So OR is removed. So what happen here? C double bond. This bond is shifted to like this. When it comes to single bond is turned into double bond. So C double bond. R is there, R. Again OH is there. So what happened? OR and Na. What removed? OR and Na. Now we have to write byproduct RONA. Simple. What happens? RONA. That is the byproducts. So step 3. In this alkoxide RO being highly basic. So immediate accept proton from carboxylic acid. So you have to write RC double bond OH plus R dash ONA. In this step, what happens here? Alkoxide, that means RO. So what happens? Alkoxide bond, that means RO minus, being highly basic. So what happens? This RO is highly basic. Highly basic. So immediate accept proton from carboxylic acid. So this proton H plus. What is the proton H plus? So basic is RO. Highly basic is immediate accept the proton from carboxyl. This is the carboxylic acid. So this hydrogen is accept the proton with carboxylic acid. Then what formation is formed? Then plus RO is attached to the H. So ROH is formed. So what happened here? The remaining main product is RC double bond ONA. RC double bond ONA, this form. So what is sodium salt of acid? This alcohol. So what happened in third sum? The alkoxide, that means RO minus, being highly basic. So immediate accept proton from carboxylic acid. So what is the reason here? RO అనేది highly basic. So this RO is attached to accept the proton from carboxylic H. So what is the formation? ROH. This is the byproduct. Coming to this topic, RC double bond O, remaining is Na. So sodium salt of acid. So we have to prove the mechanism. So what happens here? Sodium salt of acid and alcohol is formed because of ester. So what you have to take the reaction? Coming to the mechanism, they proved. So this is the most important topic, and full video and related topic also there. So subscribe చేసుకోండి, మీకు వీడియోస్ కనిపిస్తూ ఉంటాయి. థ్యాంక్ యూ గైస్.